question is, why are dimensionless numbers like Reynolds and Prandtl numbers so important for analyzing flow and heat transfer?
My name is Trahan, and I was asked why dimensionless parameters like the Reynolds number and Prandtl number are important when characterizing flow and heat transfer. So first of all, I think it's important to note that these dimensionless parameters work for any material or fluid regardless of what kind it is, and I think that's what makes them so useful. But basically, let's look at Reynolds number first. So Reynolds number essentially determines what type of flow of fluid is flowing in, I guess you could say, being laminar or turbulent. And in the case of heat transfer, that's very important because the heat transfer rate completely depends on that when you look at convection. So, if you have a turbulent flow, obviously you're going to get more heat transfer, along the surface. And depending on if it's an internal or external flow, there's a different transition number for Reynolds number. And basically, if you calculate this Reynolds number and find that it's turbulent, there's different correlations for the Nusselt number you can follow, and using those you can find the convection coefficient, and from there it's pretty much simple equations just to get heat transfer, over a surface. So I think, that one's probably the more important of the two, but the Prandtl number also plays a huge role because it relates the kinematic viscosity to the thermal diffusivity. Those two also, that one takes into account what material it is, while the Reynolds number, it takes into account the type of flow, and that pretty much governs all of heat transfer.